Hey, power people. Welcome to Renewable Rides, powered by VECKTA. I'm Gareth Evans, the CEO and founder.
And I'm Dan Roberts, head of sales. In each episode, we'll uncover the latest trends, learnings, challenges, and triumphs relating to the energy transition, on-site energy, and sustainability through the experiences of our inspiring guests and team here at VECKTA.
So get ready for an exhilarating adventure into the fast-paced world of challenging limits, adapting purposefully, and empowering co-creation to accelerate the energy transition with those that are on a mission to create a more resilient, profitable, sustainable, and thriving energy future. So let's go.
All right. Welcome back, everyone, to another episode of Renewable Rides. Today, Gareth and I are excited to dig into a question we've been hearing from quite a few customers, specific to their outlook on the grid and how they're unclear on how they should be thinking about it, whether it be the age of the grid or everybody hearing about the approach of electrifying everything, whether it be electrifying buildings, industry, as well as transportation, and how that's going to impact their businesses over the next several decades. So in this episode, we will touch on the realities of energy load growth, grid capacity, and the risks that businesses should consider for their grid energy supply. So, Gareth, thanks for joining. And what is some perspective on energy load growth?
Yeah, it's a really interesting topic, Dan, because for the last 20 years, the utilities haven't really had to worry about energy load growth. They've been able to deal with the consumption that we have today and maintain and operate their facilities around that with some certainty. And that's been because we've been getting better at being more energy efficient across our homes and our businesses, our appliances, our lights, our heavy energy users are becoming more efficient. So we're using less energy. Over the last decades, we offshored a lot of the very energy intensive industries, as well as many of us, businesses and communities alike, are now generating and storing energy at our facilities. So we don't need to necessarily consume utility grid power at the scale previously that we did. And also the utilities and the technologies around that are getting better at being able to manage when and how we when the peak demand for power comes in, such that you don't have to oversize the system to account for very rare peaks. They've been able to mitigate and manage that. But that's all about to change, and it has been changing over the last few years. And do you want to share some of the crazy stats around how we're going to go from this flat load growth to it suddenly exploding?
Yeah, no, it's we've seen some of the flattening over some great technological implementations of efficiency, like you said, but really the electrify everything is changing along with a few other factors in the technology world. But the electric load growth is expected to increase 81% more than what the grid planners had expected. So based on reports that were filed with the Federal Energy Regulatory Commission, or people might hear that referred to as the FERC, show that the grid planners nationwide expected growth to be just around 2.6%, when the reality is it's expected to grow based on new modeling at 4.7% over the next 5 years. So 81% greater than what was previously expected. And to your point, while the last 20 years have seen a lot of offshoring of heavy energy users, primarily manufacturing, we're starting to see reshoring of these types of businesses. According to the U.S. Census Bureau, construction spending on manufacturing facilities increased 40% in 2022 compared to 2021. And that growth had continued into 2023, with September seeing 62% higher in September 2023 than September 2022. So we're seeing a lot of new manufacturing facilities getting built, which is going to put a lot of electricity and energy load on the grid. Data centers, we can't overlook the fact that AI is working its way into every boardroom, every conversation. I'm sure it's working its way into the conversations around the dinner table. And according to OpenAI, arguably the leader, large language models, or LLMs, are doubling their energy consumption every 3.4 months. Now, that is absolutely staggering. According to Moore's law says that there's a doubling happening every 2 years. That's something that we saw in the semiconductor industry over the last several decades. But what that means for doubling every 3.4 months is that since 2022, that this AI load growth has seen a 300,000 times increase over that time period. Whereas if you had only looked at the doubling of traditional Moore's law at every 2 years, you'd only see a 7x increase. So pretty staggering, and who knows what's to come over the next couple of years.
That's
And
crazy.
then lastly, yeah, absolutely. And then lastly, we just interviewed in a podcast that will come out soon, Steve Pollins, the CTO of Alpha Structure, and he had shared with us that data centers, while they're consuming roughly 54 megawatts today, it's expected that they grow to not quite double, but to 90 gigawatts by 2028. So just in the next 4 years. So pretty wild stats there. Anything else to add there, Gareth?
Yeah, just to call out 54 gigawatts to 90 gigawatts.
Did I say megawatts?
Yeah, all
Yeah.
good there.
Yeah.
Just want to make sure that you're not called out by people pernickety. But yeah, it's crazy, the low growth. And that doesn't include the fact that we're going to be electrifying massive portions of our transportation sector, as well as our heating and cooling technologies. And with that, actually, what it generates, as we use more and more heat pumps for heating and cooling, it'll actually shift energy loads in unique places. So you can imagine up in the northeast of the US, where it's getting a lot colder than the West Coast, through the winter, they're going to see a significant load growth. Whereas on the West Coast, the significant load growth is coming from the cooling through the summers. So utilities don't just have to account for the load growth, it's also the seasonal impacts of that load growth, which I think is a super challenging position for them to be in. And then we've got more and more people talking about hydrogen production. And for us to do that at scale, we need a lot more energy. I think that's being massively overlooked right now. And then more and more severe weather is resulting in more and more heating and cooling needs, which we are seeing the impacts of. I think great example, Dan, a few years ago with electric vehicles. Governor Newsom came out and said that we won't be able to buy any more fuel vehicles from 2035 onwards. And in the same week was asking people not to charge their vehicles because we're suffering a heat wave, and they wanted to be able to ensure that the power stayed on for the communities and businesses in our state. And so quite a conflict of messages as this load does continue to grow throughout our country.
Yeah, it is quite a conundrum. Well, that's a really good segue. So we've been talking about load growth, but how does that impact the grid and the capacity of the grid? Maybe you can share a bit there.
Yeah, it's a challenge. I think just a few examples just so people can put this in perspective. So if Amazon suddenly decided they wanted to electrify a fleet of 200 vehicles, that would be an additional 4 megawatt load on the system. For each 18-wheeler that we want to bring or electrify, that would result in up to 2 megawatts per charge, which these are not insignificant numbers. And these have quite significant knock-on impacts in terms of how we actually manage the distribution grid to account for that. So Black & Veatch did a really interesting study where they showed that for every 5 megawatts we want to bring online, that requires us to be installing new circuits. For up to 10 megawatts, we need new transformer banks. And for 20 megawatts or more, we need new substations. And these are not insignificant cost impacts. For a new substation, you're looking at $9 million plus. And circuits and transformers from a couple of $100,000 to many millions. And this is a challenge. And Dan, we just saw the impact of a transformer going out at BP Whiting. What do you think of that?
Yeah, it's over the next days and weeks, I'm sure we'll find out more details. But yeah, pretty scary situation there in Whiting, Indiana. one of the largest BP facilities in the country, BP refineries, having lost power, and a pretty serious safety issue. Not to mention all of the larger, more long-term environmental impacts of the flaring and impacts on the local community there. I think the grid capacity is gonna continue to be a growing concern. We heard a couple months back from one of the major utilities in the Southeast that we were speaking with that they have for all the capacity that they currently have on the grid, they have service applications for equal that, meaning in their service queue to get electricity, they would need to double the capacity of their grid, which they've been building over the last 100 years. So pretty significant impacts on businesses that are looking to expand their operations, build new facilities. I was recently a speaker at an event here in the San Diego area where we had the COO, Mark Rothleiter, the COO of California ISO, or California Independent System Operator, who shared some of his perspective. And for the California grid, or what CAISO covers today, it's about a 50 gigawatt bulk power system, and by 2025 they need to expand that to about 120 gigawatts of clean power, based on the Senate Bill 100 that was signed into law in 2018, that says 100% of electric retail sales to end use customers need to be from renewable energy. So that means they need to be putting on 7 gigawatts a year for the next 20 years, which, for reference sake, for those that may not be aware of how much power that is, that's roughly enough power to power roughly 5 million homes. And then there was quite a bit of discussion around the impacts to transmission and tying into local grids and creating this kind of Western interconnect. And that all takes time as well. So he had mentioned it takes typically 7 to 10 years to develop a new transmission line. So a lot of challenges for these grid operators to both facilitate growth of industry, but also make sure that the grid operates correctly. So as a business, that's a lot to handle, a lot to consume, a lot to make sense of. What are some of the risks that I, as a business owner, should be thinking about when it comes to continuing to rely on the grid for my energy?
Yeah, I think what we're seeing more and more of, aren't we, Dan, is that as we actually are reshoring more industry that you touched on before, we're bringing some of those heavy energy loads back, whether that be a new manufacturing facility, a new data center. We're seeing businesses actually being told you can't actually interconnect to the grid where you wanted, and that you should come back in a few years' time and get an update. And so for businesses wanting to deploy new greenfield facilities, they need to be thinking long and hard about where they're going to locate them, and making sure that they're engaging with the utility early, sharing their load needs and expectations such that they can understand whether it's going to be even possible. And if it's not, they need to be seriously considering whether a microgrid or on-site energy solutions are going to be able to power their facility for their power demands. In terms of costs, due to these ramping energy needs and the aging grid, more and more money is being spent on maintaining, operating, and managing and investing in new infrastructure. And so all of this cost gets passed on to us as sort of business and personal consumers of energy. And so we need to make sure that we are planning for that. It's very hard to predict how much these rates are going to escalate. We just saw SDG&E here in Southern California pass on the mantle to Pacific Gas and Electric for being the most expensive utility in the country. And those rates are getting escalated year on year. So businesses need to either plan for that, or they need to have a mitigation plan to be able to lock in and leverage their opportunities to reduce their energy load through efficiency and generate and store energy on site to manage those costs. And lastly, power resilience is critical. Without power, our businesses do not operate. So we need to make sure that the power stays on. And so business leaders need to be thinking about how they can ensure their business continuity, manage their risks of outages, and that they've got plans in place to do so.
Yeah, it's something that I think we're more and more business leaders are starting to grasp the challenges of relying on the electric grid, both from a cost perspective. Certainly, it's working its way into conversations around how they reduce their carbon emissions, but I think it's going to be continue to be highlighted more and more, the risks on the resilience and reliability side. You just mentioned PG&E taking the trophy as the most expensive utility in at least the lower 48 outside of Hawaii. And yet this week alone, we've had this atmospheric river running through the state, and there's been over 800,000 customers in PG&E territory without power. One thing that has been pretty staggering to me that I've learned over the last several months about our grid infrastructure. So according to the Department of Energy, they found that the average age of large power transformers, which these large power transformers handle 90% of the electricity flow in the US, the average age of those is more than 40 years old. So we're relying on equipment that is more than 40 years old. Yet, when a transformer is operated under the ANSI, or American National Standards Institute, or the IEEE Institute of Electrical and Electronics Engineers, the basic loading conditions say that the normal life expectancy of these large power transformers is about 20 to 30 years. So we're saying an average life expectancy is 20 to 30 years, yet the average age of those that we're relying on the grid is 40 years old. These are failing, and they will continue to fail at a more rapid rate, which presents pretty significant risks to businesses.
Yeah.
So I think it goes without saying that it's not all doom and gloom. More and more companies have options. You don't have to rely on the grid. Gareth, maybe you can touch momentarily on what businesses can do.
Yeah, I just want to actually double tap on that commentary, Dan. I think what you were talking about in terms of the substation upgrades is to just maintain the existing grid infrastructure, let alone adapt to the load growth that we talked about before. And you mentioned building new transmission lines. You're looking at 7 to 10 years. Right now, there's a lot of projects wanting to interconnect to the grid that are going to bring in awesome, clean, renewable power. But the shortest interconnection queue is in the PJM, the utility territory, and that's 37 months. And the highest is in the Southwest pool, and that's up to 70 months. And so it just shows that if as a business we're relying on the fact that the utility is going to figure it out for us and they're going to continue to provide us that affordable, reliable power, we could be waiting a while. So yeah, the options are really reduce your energy load as much as you possibly can. Energy efficiency is a really cost-effective way to minimize how much energy you actually use. The less energy you use, the less energy you need, the less it costs. And so that kind of removes some of the risk. And then, being able to assess and deploy on-site energy solutions where we can generate and store energy right where we need it and take some of that kind of energy sovereignty control into our business operations. It allows us to hedge our operating costs, being able to lock in an energy cost for the next 15 to 25 years versus suffering anywhere from a 5 to 40% cost escalation year on year. It provides a lot of business sense. And I think we need to all believe in the fact that the misconceptions of the past that sustainability and profitability can't be achieved together. These systems now allow us to reduce our emissions, increase that resilience, and lower our costs. And I think last piece of advice would be to make sure that businesses if they know that they've got energy load growth, whether they're installing new EV charging stations, new equipment, whether they're switching out fossil-powered assets for electric ones, they should be having a conversation early and often with their provider, the utility provider, making sure that they have access to the capacity they need, or looking at the options that we just talked about. That's kind of my outlook. Any additional thoughts you'd add to that, Dan?
No, I think from my perspective, I'm eager to see how things play out through the rest of this winter, and with the growth in technology across AI and the growing need for data centers in general, even beyond AI. I think we're going to see some pretty interesting decisions transpire, both for grid operators but also for businesses. The energy system, I'll call it, that we know today is going to look very different in 5 years, let alone 10, 20, 30 years from now. And I think we need to all open our mind to what the possibilities are, and recognize that we can take more control and not just be passive consumers from the grid of the past.
Yeah, completely agree. Let's build the energy infrastructure of the future. It's possible today. We know that the equipment, the capital, the construction capabilities all exist. A big part of our job and our podcast here today is to help our business leaders and community members understand that there are options, and we can't wait around and be those passive consumers. So really enjoyed it.
Likewise, let's get after it.
All right. Cheers, Dan. Have a good one. We receive a lot of questions from business leaders around the world wanting to learn more about the energy transition, what is possible, and where to start. So to help you stay informed and up to date on best practices, opportunities, risks, and success stories, we created an industry newsfeed at VECKTA.com/news with all our podcasts, blogs, and newsletter. Check it out and connect with Dan, myself, and the VECKTA team to learn more. Cheers and have a good one.